Testing, testing. Hello. We're going to get started in just a minute or a couple minutes. We'll wait for some people to arrive. We're already a minute early right now. And if anybody is watching already, let me know in the chat if you can hear me and see my screen. It's always good to confirm. How is everyone doing today? All right, I see quite a few people here already. Awesome. Before we get started, too, while we're kind of getting going, let me know in the chat why you're interested in computer vision, if you're already building something with computer vision, if you've ever done maybe some sort of ML monitoring before, or you don't have to share specifics, but it's always fun to hear about kind of some sort of failure that you've had in the field, specifically with computer vision in this case. Like, have you had bad quality data? Have you had models gone wrong? We'll talk about that in a little bit, and I'll share some examples that I've seen. But it's always fun to see kind of what the audience has experienced as well. And while we're waiting, just another minute before we really get going, I'll share a couple links. Let me just get my screens situated. The main one, well, there's going to be a few, but one, if you want to stay connected with people, after this workshop, specifically if you want to stay connected with me or ask questions about anything we cover later, you can join the Slack channel. So that link should work. If you're watching on YouTube, I'm also streaming to LinkedIn, but if you're watching on YouTube, all these links should be in the description below. So you can go ahead and open up the Slack if you want to join it. And then there's a couple other links. There's just one for setup, and I'll share this again when we get closer to it. But there's this WhyLabs sign up free. It's the tool we're going to be using today to monitor our computer vision models. So that's the only thing you need to do to really get set up here. And again, we'll cover setup in a little bit, but it's just making one account. Otherwise, you need a Google account, and most people already have that, and we're going to use Google Colab today. So I'll give just one more minute before we get going. But it's awesome to see so many people already here. And yeah, let me know in the chat again if what you're working on, if you've used computer vision before, and if you've done any monitoring on it, or just if you've seen failures. Like, what kind of failures have you experienced? Also, you can just say where you're watching from. That's always fun to see as well. I know sometimes streaming, there's a little bit of a delay. So when I ask a question, I might pause. It might seem for like a long time, but it might be me waiting for your response. And all right, let's go ahead and get going. Again, if you're just joining, say hello in the chat. I think it's fun during live events to interact somewhat with other people, either the people talking, me in this case, or other people kind of attending. And it's kind of fun to see everyone's backgrounds and staying connected. So I'm going to share this screen. This is computer vision and monitoring. We're going to build and monitor computer vision models today, and I'll talk a little bit more about what that means in a second. What this workshop is hopefully it's going to be a friendly introduction to building and monitoring computer vision models. We're going to use TensorFlow, more specifically the Keras API built into TensorFlow, and WhyLabs, which is a tool for monitoring data and machine learning models. So no previous experience is expected, but knowing some Python and machine learning concepts are going to be helpful. But I will do my best to explain as we go. And so even if you've never trained a computer vision or a deep learning model before, if you just stick around, you'll be able to run all the code and train one yourself. So that's also super cool. If you've never done it before, this could be your introduction kind of to computer vision. What we're going to do is we're going to cover some high-level concepts and slides. There's not that many of them. We should go through them pretty quick, and then we'll get to hands-on code very quickly. And just keep in mind, you can't learn everything in an hour. We're going to be going through a lot of stuff, especially if you've never done deep learning or computer vision before. So if it feels fast-paced or challenging, that's totally okay, depending on your experience. You might even expect that. So the thing is to keep learning after this workshop, take what you learned here, and apply it to your projects, whether that's personal projects or real-world ones. And this is a little picture of, we're going to train a computer vision model on our own data today, and we're going to be detecting Raspberry Pis or a Jetson Nano. They're both kind of mini computers that you can use to do computer vision on the edge. A quick introduction about me. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at WhyLabs. We create a lot of cool products for enabling AI observability and ML monitoring and monitoring data through your pipelines. And again, we'll cover a little bit about what this can look like for computer vision in a few minutes. And for about the past decade, I've worked in software, machine learning, and doing a lot of hardware stuff with startups, mostly in Seattle, but a little bit in Central Florida as well. And I love making things with technology, so I don't know about you all, but I always have a ton of different little side projects going on in various states, and I think it's really fun. About you. So again, I see some more people joined. If you want to put in the chat, it definitely helps me out presenting, but also I think it's fun for other people watching live to connect with other people. So where are you watching from? Why are you interested in ML monitoring? And then again, like I was saying, there's a link in the description below if you want to stay connected in the Robust and Responsible AI Slack channel. It's a good place to introduce yourself there so that people can stay connected. And if you want to ask questions about anything we covered today, that's going to be the best place to do so. So setup again, I talked briefly about it. You just need a Google account for Google Colab. If you don't know what that is, don't worry. I'll go over it when we get to the coding part. But it's where we're going to run our code today. And then you'll just want to sign up for a WhyLabs account. Again, it's free. There's no card or anything required, so it should just take you a minute. And then we're going to be using TensorFlow, like I said, the Keras API in TensorFlow. And then we're going to be using an open source library called WhyLogs. And then we're going to be using the WhyLabs platform to look at our data and monitor the model and see how it's performing. So instead, they're currently working on an AI model that classifies conspiracy theories. Ooh, that's interesting with like NLP. I'd imagine it has to be, unless it's in images. Right, so real quick, what is TensorFlow slash Keras? So TensorFlow is a library maintained by Google, and it's incredibly popular for deep learning, used a lot in computer vision, NLP. It's great for transfer learning. There's a lot of pre-trained models you can take and then fine-tune, which is what we're going to be doing today on our data. So we're going to take a model that works really well at detecting some things, then we're going to pass it new data, our own data, and then it should get pretty good at detecting that new piece of data we're going to train it on. So one cool thing about TensorFlow, like people always talk about TensorFlow versus PyTorch, they're both great libraries. You should just get started with one. One thing I do like about TensorFlow, though, is its deployment ecosystem's really cool. I mean, PyTorch has a lot of great stuff, too. But you can use TensorFlow on the web with TensorFlow.js if you want to make a web app. There's a lot of really cool mobile stuff and tools to help you compile your model for even embedded ML. So like running on a smaller Arduino type chip and stuff like that. There's a lot of cool packages in TensorFlow for this. So what is ML monitoring? ML monitoring is the collection of statistics, performance metrics from hopefully every part of the ML system, but really at bare minimum, you should be probably tracking the input data to your model and then the output of your model, and then hopefully the ground truth to see how it's kind of performing over time. And we're going to cover how to set those things up today, and those are kind of like the first couple things I would say to get started with if you don't know where to get started. So just kind of a quick little overview. You have your production environment. This could be like your inference, your training, your feature store. We're going to use a tool, like I mentioned earlier. It's going to be an open source library called WhyLogs. That's going to collect some telemetry. And then we're going to pass that to a platform and kind of observe this data over time. So we can create or do actions based on those insights. So that could be automatically kicking off some sort of another job, like a retraining of a model, or just providing data to like your business team or data scientists. So why is it important? We have a saying, bad data happens to good models. So you could train your model and it could be doing great on your evaluation data sets, your training data set. Once you put it in production, chances are things are going to change. Has anyone here put a model in production before? Let me know in the chat. And if you have, you'll probably notice that it doesn't always work as well as you want, or at a certain time, like the data is going to change and the model performance might degrade. So the couple things that can happen here is like you have data quality issues, data drift issues, concept drift. We'll talk about these a little bit more in a second. And then you might have things like your model might be biased, or you want to have explainability to see why your model's making these decisions that it made. So a couple data quality computer vision examples. You might have some external changes, like an input sensor is damaged, in this case for computer vision, like a camera, or you could be using some other, you can use computer vision models on audio and different different types of data as well. You could have a camera that gets moved, so it's like pointing in the wrong direction now. You might have a light that gets turned off. I've had that happen before in production. So even if you're deploying computer vision models into a relatively controlled environment, let's say a manufacturing floor, and you think, well, weather is not going to be an issue here, lighting shouldn't be an issue here, something's always going to happen, or maybe not always, but pretty often, where like a light changes, or we'll see some other examples actually in our model today where the color changes, and that throws off our model. You might have a library that gets updated somewhere in your pipeline, and it now your data looks different than you expected. Data drift. So input for predictions are no longer as close to the original data. So one example could be that in computer vision, if you were training a wildlife detector, let's say we're detecting geese, and all of your models in the summer, so these geese are on grass, green grass, and then all of a sudden you are trying to predict detect the geese in like a different color background, like brown grass, or if there's snow on the ground, I think they migrate, so they might not be in the snow. But if this big color shift happens and your model isn't trained for that, there's this big shift of your input data now, and chances are your model might not be making as good of predictions anymore. So that could be things like seasonality changes, lighting, again, like I talked about, schema, or like the lighting examples of one that I've seen a lot. And again, what examples have you seen? Let me know in the chat. If you've deployed a model and experienced some sort of data drift before, let us know in the chat. You also might have something called like concept drift, where you trained a model and then it's no longer giving you the predictions that you want, like it no longer maps correctly to like a good prediction. So one good example of that is the housing market, and often use a prediction example, like if you were looking at number of rooms in square footage and you trained this model 10 years ago, well, the prices of houses have gone up immensely. So it no longer does the right prediction. It's now kind of old data or old prices that it's predicting. So in that case, you'd want to update your model with the current prices. And computer vision, for a computer vision example, you could actually think, I know some of the big real estate companies will use computer vision to look at images that get uploaded and kind of do some sort of price prediction on that. So again, if you trained this on houses from years ago and now it's predicting, well, this house is only going to be 60K, but really it's like 500K, your model is no longer very useful for that. So in that case, like the input data isn't actually changing, but the output no longer matches the examples. Some other areas of data and ML monitoring. And actually, I'll share a link in a second, but I'm going to be covering these in upcoming workshops. We're going to talk about model explainability. So like I said, kind of understanding why your model is making these predictions. And then bias and fairness, like is your model performing certain ways on different classes or segments of data? And you want to kind of see why. We'll be covering those. So that's enough slides. Let's go ahead and get to the hands-on part. First, real quick, I will share a link to those upcoming workshops. So if you do want to join in, you can join here. You can go to whylabs.ai/events, and everything should be listed there. All right, so to follow along, which I hope most people want to follow along, I'm going to put this code in the chat. And again, it's in the YouTube description below as well. I'm going to share this real quick in the LinkedIn chat as well. So give me a second. Just open up that link. That's going to bring you to a Colab notebook. And I'll open it up as well in a second. Let me just make sure this gets shared. Oops. Try one more time to share this link. All right, so this will bring you to something that looks like this. And also, the link is in the notebook, but you'll want to sign up for this free account. Someone said the Colab notebook says notebook loading error. Can someone else confirm, were they able to open this notebook? If you do get an error, try loading again. Let me double check. This should work. I've shared this out before. It could be a Colab issue or an internet issue. Colab does go down sometimes. I just tried it in an incognito tab for me and it works. Someone else said they can open it. So the person who had the error, sorry, maybe try again. Maybe try it in even a different browser window if it for some reason doesn't open there. but other people are saying they can't open it. All right, so what you're going to want to do to run all this code and be able to edit everything and have your own copy is go to File, go to Save a Copy and Drive. I'm going to do this as well. And again, links to the signing up for the account is here, as well as looking at our GitHub and our Slack channel. So I will share real quick too our GitHub link. So this is for the open source library that we're going to be using today. And as always, if you give it a star, I always appreciate that. All right, so once you have your own copy, were people able to make a copy? I'll give everyone a second to do that. And while you're making a copy, again, just go to File, Save a Copy and Drive. This is Google Colab, so it's kind of Google's way of hosting a Jupyter Notebook. If you've never used a Jupyter Notebook before, it's a really cool tool that a lot of data scientists and machine learning engineers use. It allows you to write text, so kind of like documentation, embed images, and run code all in like a single place. So it's really cool for experimentation. It's great for teaching. It's great for learning. It's a really good way to kind of experiment around with code and visually see what's going on. So this is Google's way of kind of hosting that for you. Quick note, you can also change this runtime. You don't need to do this for this workshop, but you can change runtime type. If you copied it from my copy here, it should be set to a GPU because we're going to train a deep learning model today for computer vision. But you can change this to a CPU or a TPU, and they give you a good amount of GPU time. So if you're learning deep learning or computer vision and you don't have a GPU, like you don't have a gaming computer, this is a really good way to get some free GPU hours and start learning deep learning. All right, so let's go ahead and print hello world. So this is going to run our first code cell. You'll see it might take a minute to initialize a whole environment because Google actually gives us a whole little Ubuntu instance here. It's not just running code. So you can actually pip install new libraries in here as well. So once this first code cell runs, we should be pretty good. And we know that our environment's running and everything should run faster now. So a little bit of setup for this project. We're going to pip install Pillow. It's a image processing library. I should also mention Google Colab comes pre-installed with a whole bunch of libraries. So like you'll actually see we won't pip install TensorFlow because it's already installed here. And Pillow was installed, but we wanted a specific version to work with the WhyLabs library here. So let's install that. And this is very important. If you're watching here, if you don't restart this runtime, the new version of Pillow won't be in our kind of environment right now. So you have to hit this restart runtime. Otherwise, part of this might not work. So hit restart runtime. You'll see it's initializing up here again. And now we're good to go. We can start running these other code cells. So again, make sure you hit that restart runtime. If you don't and you get an error later, that might be what happened. So let's go on. Just a little bit of setup. Again, we're going to pip install WhyLabs and pass in the WhyLabs dependency. So we're going to get a little extra stuff so we can write our profiles to WhyLabs. So I'll just talk about this while this is installing. So WhyLabs is an open source library for logging data pretty much of any kind. With WhyLabs, it's pretty cool. We create profiles. So we look at a whole data set that you can pass in, and then we just create these kind of summary statistics about them. So when you then write your profiles up to WhyLabs, like we're going to do today, it doesn't actually contain any raw data. So for images, this looks like we'll actually go see all the parameters. But for images, we have a built-in image function where it extracts features like the mean brightness, the saturation. But you can write your own metrics. So if you wanted to get something more specific for computer vision, like what is the brightness of an area inside a bounding box, or how many bounding boxes were there? How big are those bounding boxes for object detection? You can log those metrics as well. But one great thing about them is also they're super efficient. Like I said, they're customizable. They're also mergeable. So one thing that's nice, I've done a lot of computer vision work with like edge devices. You don't always have a solid internet connection. And so like sending images out of an edge device can be really costly, especially if you're on a mobile network. So if you actually just want to monitor to see like, is the data drifting or not, you can actually send these really lightweight statistical profiles, and they're way lighter than images. And then if something did drift and you want to go get the data, then maybe you ping back and get just that chunk of data. And we'll see how to use this again in a little bit, but it's very easy. You just import WhyLabs, and then you just call y.log on your data. So it could be a data frame. An image looks a little bit different. We'll see how to use that. And then it could also be like a Python dictionary. Right, so we installed WhyLabs. Let's go ahead and import our libraries. We're going to import TensorFlow, Keras, some stuff to build models there, and then we're going to import WhyLogs and the log image method and the WhyLabs writer, and then some other libraries like Pillow that we previously installed. So just one last piece of setup. Once you put in these three things, we should be able to run through things very quickly. We want to get three things from WhyLab, so hopefully you already made your free account, and then we'll open up the homepage. We want to get our API key, our org ID, and our model ID. So again, you can go to that whylabs.ai/free. A link should be in the description on YouTube. And you should have a page that looks something like this. You shouldn't have a model. I have one already here that I've run. But what we want to do is hit Create Project. Also, I'll just give everyone like a minute if you haven't created the account yet. And if someone wants to let me know in chat that they were able to create the account and get in, that'd be great. All right, so we'll go to Create Project. We want to set up a model. You can add a little demo model here, but today we're going to be working with our own data, which I think is more exciting. And then we're going to give this a name. So name this something relevant, whatever you want. I am going to call this CV. What's the date? Oh, it's March 1st already. I was thinking it's still February. Let's call it CV March 1st, but again, you can call it whatever you want. I'm going to get select the type of classification model. That's what we're going to be training today. But you have some other options like regression, other model, batch frequency. This just means that it's going to basically, well, we'll see what this actually looks like when we upload our data. But essentially, this is saying, give me an alert if something went wrong every day. So it's going to wait 24 hours. It's going to look at our data, and we'll set up a monitor, which we'll see in a second, and it'll say, hey, something looks like there's an anomaly here. Maybe you want to go look at it. So let's hit Add Model or Dataset. Now we have this model ID to the left. Yours is probably model 0 or model 1. Mine's model 92. I'm going to copy this over. So I'm just going to highlight it, or you could type it out. I'm going to go back to my Colab notebook. I'll copy it into model ID there. Make sure I picked up an extra space there. Make sure there's no spaces in anything you're going to copy over here. So let's go back to WhyLabs. We can go over to this other little tab here, Access Tokens. And then I'm going to create a new token here. This is our API key to allow us to write to it. And again, I'll just call this the same thing, but you can call it whatever you want. CV March 1st. You can add an expiration date to this token if you want as well. And then we created it. We go ahead and hit this copy button. Go back to the notebook. Put in our API key, no spaces, looks good. One more time, let's go back to WhyLabs. You can see our org ID is in a couple places here. So it's listed here, here. It's also in our little profile drop down. So I'm going to hit that little copy button there. Go back and then put in our org ID. And again, make sure if you copied from text in the page or anything like that, that you didn't pick up any new line or extra spaces. And then go ahead and run the cell. And I didn't mention at the beginning, so you can click this little play button. That'll run the cell. I often hit Shift-Enter, so you don't see me clicking it. Once the cell is highlighted, Shift-Enter will run the cell and move to the next one. So it's good if you want to run things quickly, you can hit Shift-Enter, Shift-Enter, Shift-Enter. So now we ran this, and we should be all set up to kind of run all the other code in our project now. So let's go. Let's download the dataset. So I mentioned at the beginning, we're going to be training a model to detect two different classes, Raspberry Pi and Jetson Nano. And inside our dataset, we'll get clone it. Inside our dataset, we're going to have training data, validation data, and then we're going to have sets of days. So we're going to kind of emulate running this model for days and see how that model, how the data might change. So if we looked in here, we can see there's two folders. One is the sample data that is in here by default in Colab, and then the other one's our data set. And we can look in that folder and see there's folders for each of those things I had just mentioned. And we'll take a closer look at the data in a little bit, but let's go ahead and train our model and then log what it looks like. And then we'll come back to the data and see maybe why, spoiler alert, maybe something isn't working the way we want it to. So in Keras and TensorFlow, we set up something called a image generator. So this is, or data set generator. So this is just telling us how to read our data set in to train our model. So often you do things like resizing, set batch sizes. So saying how many images are you going to load in at once to train your model. So we have some parameters here like image size. We're going to condense our images to 180 by 180, and we're going to load 10 at a time when we train our model. So we just use our preprocessing image dataset from directory. So it's going to look in this directory, see that there's two classes in our training dataset. There's the Pi and Jetson. So it knows it's going to be two classes. And then we do this for our training dataset and our validation dataset. And if you haven't done deep learning before, you typically have 2 or 3 datasets. One is your training. That's what your model learns from. Then you have a validation dataset. As your model is training, we'll see this in a second, you're going to be comparing the results to your validation dataset, see how it's doing on data it's never actually seen before. And then you might have another holdout test set that when you're done there, and if you've done any hyperparameter tuning based on feedback on your validation dataset, then you can see how it did on this other dataset. So let's look at what our data looks like right now. We're just going to read in 9 images here and see what it looks like. You can see, so this is a Jetson Nano. Again, like I said, they're both kind of little computers that you can run. You can run all sorts of things on them. I use them for machine learning, computer vision, and robotics projects. And we can see this is a class 0 as our Jetson Nano. It's kind of this darker, bigger board. And then a Raspberry Pi is class 1. So we have different variations of this. And you might look at this just as a hint for what's upcoming. What's similar about all these images? Just keep that in mind. We'll see a little bit later. So let's go ahead and also log our training data set. The reason why we want to do this, we'll see in a little bit, is what we're going to do is create basically a profile of our training data set. So this is going to take all those images that is in our training data set, get the average like brightness of them, those other statistics that we'll take a look at in a little bit. We're going to log that as a reference profile to WhyLabs so that we can look at any new data coming in and say, does this new data look similar to the data that was in our training data set? And if not, maybe we want to throw some sort of a alert saying the new data no longer really matches the distribution of our training data set, so your model may not be performing as well as it could be. So we're going to initialize the WhyLabs writer. We'll read in our data set, and then we're just looping through the data here, going through those directory, so the training data, the Pi and Jetson path. And then we're creating a merge profile, so we're creating a profile for each of those images. Again, we'll look at those stats in a little bit, but again, just imagine getting like the average brightness for an image, and then we're merging those profiles together, and then we're uploading them to WhyLabs with this writer.write. And we'll see this, the how to write profiles again when we get to the training results, or sorry, the prediction results. But for now, just keep in mind, we took a profile of our training data set, pushed it up to WhyLabs so that we can use it for comparison next. And if we look at our profile, this is what it looks like. So here we have, again, we'll look at all these a little bit more in depth in the platform, but you can see that we have cardinality, which tells us there's about 68 unique images or data points. And then you have things like the brightness mean distribution for all these different images. And again, we'll see this in a better presentation before. And if we looked at our data generator, when we loaded in, we can see that there were 68 images in there. So that's why we had that cardinality, essentially saying how many unique values are in here, and each image is slightly different. So there's 68 unique values. Again, you can learn more about logging image data with WhyLogs in the GitHub or docs. I'll just paste a link in the chat for that. But you should have this notebook, so all these links are in here as well. All right, so right before we train our model, we also will talk about using image data augmentations real quick. Let's actually run this just so you can see what this looks like. Augmentations are a really good practice in computer vision. Essentially, you're taking each image and then adjusting it slightly, because this is going to allow for it to generalize better on images that weren't in the training data set. You can read about this here. And if we take a look at what this means, or what this did to our image, we're telling it we want to horizontally flip it, and we want to do random rotation by just a little bit of degrees. You can ignore these warnings. That's actually a new thing that happened for me. I think it's in the latest version of TensorFlow. It's saying the way it's set up isn't super efficient, but everything should work here. So you can see that this is all the same image, but a couple things are happening. So it's basically just getting adjusted slightly, right? So this is called data augmentation. You're taking your training data set and then you're just adding kind of variations to it. And so you can do things like changing color. You could do like saturation of images. You can flip it. You can move it around. There's all sorts of different augmentations you can do. So go look at that TensorFlow link, and it's really good to think about like what are all the variations that you see in the world of this data that you want to train a model on. Because right, like if we're looking at something like this, it won't always be facing the same direction. So we want to make sure the model sees different variations so we can throw in. So then let's configure the data set for performance. So TensorFlow has some really cool things you can call just auto tune on this, and it will look at your environment and kind of try to make the best adjustments for reading your data set. So we're just going to do that on our train and validation. Again, you can ignore this warning. Everything should work fine. All right, so let's get to building our ResNet 50 model. ResNet 50 is a powerful computer vision model for classification. I forget the date when it came out, but it got really popular and was blowing away all the competitions at the time, and it still works really good for classification. And we are going to create a function here. We're going to pass in input shapes, number of classes, and then we have this argument called weights. We're going to pass in ImageNet. So this is when I mentioned transfer learning at the slide part, where essentially we're not starting from zero. We're going to take this pre-trained computer vision model that's really good at recognizing a certain amount of classes. So I forget all the classes. There might be like 51 of them, and it might be able to recognize like people, dogs, bikes, things like that. But it's not trained to recognize a Raspberry Pi or a Jetson Nano. So we're going to take this pre-trained model, and then you're going to see in a second in this code, we're essentially just going to cut off that final prediction layer that would put out those things like dog, bicycle. And then we're going to add our own layer, just predicting two classes, in this case, the Jetson Nano and Raspberry Pi. And then we're going to fine tune it. So we're going to pass in our new data, and it's going to use its existing kind of knowledge of colors and shapes, and then learn about our new data and make the predictions that way. So transfer learning is just a really cool way of like basically not starting from zero. Otherwise, you would need way more images, way more time to get kind of any good results at all. So we're going to start our pre-trained model. The include top equals false. That's the part where we're saying this is going to get rid of that prediction layer, and we're going to pass in our own prediction layer. It's going to be the input shape of 180 by 180 for images. We're going to pass in our number of classes, so we're just going to be predicting 2. And then we're going to adjust our input shape, and we'll see actually a visual representation of this model in a second as well. And then essentially, we're just adding in that last prediction layer. And there's a little if statement here saying if it's 2 classes to use a sigmoid activation, and if it's more than that, use a different activation function. So basically, we're just saying if we were doing more than 2 classes, we're going to use a different kind of function at the end there because they work better for those different types of predictions. So in this case, we just have 2 classes. And then let's go ahead and initialize our model, passing in that 180 by 180 with a depth of 3. That means it's a 180 by 180 image with red, green, blue values. And then our number of classes is 2. And this will take just a second because it's going to download those weights as well, so we're not starting from 0. And then let's look at our model. So this is the model we just built, and there's a lot going on here, so don't worry, we won't go through everything. This is a way of like visualizing what the deep learning model looks like and how everything's connected together. So if you kind of want to see what this looks like and see the extra layer that we added and stuff, you can do that here. Otherwise, though, if you haven't used computer vision before or an ImageNet, like go Google ImageNet and you'll see some good examples of what the architecture looks like. Get rid of this big output. All right, so let's now go to train the model. And we're just going to train it for 3 cycles or epochs. So that means we're going to look at our whole data set basically 3 separate times and learn from it. And that's not that many times, but we don't have that many images. This is kind of a toy example. We're going to train a model to make predictions for Raspberry Pi or Jetson Nano. And we're just going to use, like we saw, the training data was 68 images, validation was 10. So normally in your actual project, I'd recommend getting hundreds or potentially thousands, depending on what you're actually trying to do and learn. But just for this example, we're just going to train on just 3 cycles of our data and see how our model does. And so we're going to save a little checkpoint. And actually, if you open up this little folder in Colab, you can now see that we have 3 versions of our model. So basically every cycle, it saved a version. And then we could choose which one to load in, which we do here. So we're going to load in that number 3. And now we have our model. How's everyone doing so far? I know we've gone through a lot, especially if you haven't done a ton of TensorFlow or Keras before. I know it can feel like a lot, and trying to explain it as we go, but also trying to get through all the material. So just want to do a quick check-in. Is everyone following along? It's going to get, I think, very exciting now in the next minute, because we're going to make predictions and kind of see how our model's doing. So you can go ahead and run this code cell. What we're doing is reading in a image, and then we're basically just going to be making a prediction on it. So we're just using the pre-processing. It's going to change it to those dimensions that we had for training, and then we're going to make our prediction. And so here we can see that it says this image is a 0.0% Jetson and 99.99 Raspberry Pi. So this is very confident that it's going to be a Raspberry Pi. Do we think it's actually going to be a Raspberry Pi? Does anyone want to make a guess? I guess you could look at the image URL here and probably take a good guess too. So it is a Raspberry Pi. So in this case, this image in our validation data set was able to predict that it was a Pi. Let's do it for another one. This one is a Jetson, and it's 100% sure it's a Jetson. Very confident. And it is. So it definitely learned that, this green board and this dark board are different, and it's now making, at least just from our couple examples here, pretty good predictions on what they belong to. So let's go and now make a prediction for all those days. So there's 7 days of them. So I'll run this code cell and then come back to it in a second what's going on. Basically, we're doing what we did up here, where we're reading our image, making predictions, except for we're kind of looping through those 7 days that were in our dataset folder. And we're also making a Python dictionary so that we can save this output. And we'll play with this output a little bit later in a data frame. And then we're also logging our images to WhyLabs. So we're initializing our WhyLabs writer. And once we read in our image, we're going to profile that image. So this is profiling an individual image. We're calling log image, passing in that image that was read in, .profile. And then we're setting the timestamp. So by default, when you upload a profile from WhyLogs to WhyLabs, the timestamp is going to be the date and time that you upload it, but you can overwrite it. So when we're looping through those 7 days, we're going to change the date time back a day for each one. And then this writer.write is actually pushing the profile up to WhyLabs. And then we're making those predictions just like we were before. And then we're saving this in a dictionary that we're going to create a data frame out of in a second. Okay, so we can look at this output, and we see that it did a whole bunch of different predictions here and the confidence score. Now let's go into the WhyLabs platform and see what our data looks like. So let's go back. I'm going to hit the WhyLabs logo here. It's going to go to our homepage. It's going to take me to this project that we just made. There's a little summary tab in here that's pretty cool. It gives you some information. You can add new widgets. So if you add things like explainability and stuff, you can add those in here. But for now, let's go ahead and just go to this input tab. And let's click on this image brightness mean. And now we have a visualization of some data. So what this did was it looked at all the images for each of those days. And then it got those metrics that we talked about, like it has brightness mean, standard deviation, image color space, hue mean, pixel height, pixel width, and image saturation. And again, you could add your own custom metrics here. So depending on what you're looking for, you might want to adjust these in WhyLogs. But we can see just looking at this brightness mean that there's some changes going on in our data. And so this first day, the brightness is pretty high. The second day, brightness is pretty high. This third day, that looks like a big change to me, right? Like the brightness dropped significantly. And then this fourth day is closer to the first two. It might be a little bit less. And then this fifth day, that's a even bigger drop than the other one. And this is about the same, a little bit less. And then this last one looks crazy different, right? Like that's really dark compared to these first images. So again, these are aggregates of those profiles for that day. So in this case, we can see that like almost all of these are very bright and almost all of these were very dark at the end here. So this is cool. We can see already that something might be going on with our data. But of course, it's awesome to come in and check this and visually look at it. And we'll go look and see what the data looks like in a second. It'll be very interesting. But first, I want to show that instead of me having to come in here every day and look at this data to see what's going on, I can set up something called a monitor so that if the data changes drastically or in a way that I want to look for it, I can automatically get notified by email, Slack, or do some sort of integration that might even kick off an automated training job or annotation job. So I'm going to go to set up monitors. You can click this button here. We have some options. So like we want to detect for data drift, data quality, model performance. And then you can also do a custom one. So you can get really interesting with this monitor configuration, look at all these different details that you want and do something based on it. So what we're going to do is this data drift and model inputs, and we're going to be looking at numerical values. So we'll go ahead and select this one. Instead of just enabling with one click, I want to go ahead and hit configure, and we'll look at what this looks like and what it's actually doing. So go ahead and click configure on this. If you hit these little edit buttons, you'll see what's going on. So here we're detecting data drift like we selected. And then here we're going to be looking at the entire data set. We have an option. We won't go into it today in the workshop, but you can segment your data. So you could do it on classes or color and create kind of segmented profiles. And then so you could do just specific segments, which is kind of cool. But one thing we want to change here is I'm going to go ahead and make this a little bit more lenient on changes. So we're going to say, only notify me if a big changes, if a big drift happens in our data set. So I'm going to change this to 0.9. So saying when there's a drift of over 9 based on the Hellinger distance, which is the metric we use in WhyLabs to measure it, trigger that an anomaly was detected. And then on this baseline, we can see that by default right now it's looking at a trailing window. So this is going to be kind of looking back at the last 7 days and seeing when a major change happened compared to those other profiles in that day. And you can select longer ones. So like if you have a lot of data, you've been in production for a while, you can select 90 days. So look at these 90 past days. And if something drastically changed based on those 90 days, trigger an anomaly. That's really good to count for some seasonality and stuff too. So like lighting might change slightly and you want to be looking at that stuff. And then if it drastically changed, an alert. But what we're going to do is, remember we created that profile of our training data set. We're going to select that as our baseline. So we're going to say, if our profiles drastically shift out of the baseline from our training profile, meaning that if our new data coming into our model looks very different than what it was trained on, we want to know about it. So give us a email and Slack alert. And you can set up your email and Slack very easy just in the notification setting page, as well as an integration with PagerDuty. So like I said, if you want to kick off some sort of automated annotation or training job, you could do that with PagerDuty. So let's go ahead and click save. Just make sure you did those things if you want to get the exact same results, but feel free to play around with it as well. Maybe you want to look at what the trailing window looks like. But in this case, right, we changed the distance metrics to 0.9, and then we're going to be comparing it to the reference profile. So go ahead and hit save. And then let's go back to the input page. So this tab up here. Let's go back to that image brightness mean. And then now we have a monitor set up. So we can see that by default, right, I'd mentioned it's going to trigger every 24 hours. So it says in about 5 hours it's going to run. But we can go ahead and hit a preview. So click this preview button. Take a few seconds. And now we can see that when we were comparing to our baseline training profile, that all those things we kind of called out that look very different, these were flagged as this data looks different than your training data set. And we don't know how the model's performing on it yet, so maybe it's fine, maybe it's still making good predictions, but likely the chances are the confidence and accuracy of the model probably isn't quite as good if it changed drastically from the training data set. So let's go see what this data looks like now. And I think I see there's a question I'll get to in a second. But I'm going to go back to the slides real quick. And we can see maybe why our model is now making these predictions. So, or why our monitor was catching, differences. So here we have our training data set. We saw some examples of earlier. We have the Raspberry Pi and the Jetson Nano. And I think the question was related to this. Is the model based on the color of the microcontroller? So the deep learning model, we didn't explicitly tell it to look for colors, but chances are if you're training a convolutional neural network like that and you have these colored images, it's probably going to start picking up on some features of like color. So it's probably looking at green and this black for these boards and saying when it's green, it's probably more likely to be a Raspberry Pi. If it's black, it's probably more likely to be a Jetson Nano. And that's what I mentioned. This can happen. Actually, we'll see it in a second. But like, if the color of the background changes, that can really affect the performance of your model. And we'll see exactly that here in a second. So this is what day 1 looks like. And if we look back at that platform, we can remember that day 1 and 2, these are very bright. This changed quite a bit, and then it looks more normal. And then these last 3 changed quite a bit as well. So day 1, this looks very similar to our training data set. Approximately same lighting, same background. Again, day 2, this looks very similar to our training data set. Same lighting, same background. Day 3, this looks very different. What happened here? The camera is really zoomed in. So, it's no longer looking at the whole board. We're just seeing parts of the board. And in this case, like you mentioned color, though, if it did pick up on color mainly, and that's how it was making the decision, the model actually still might perform well if it's just looking at dark versus green. Maybe it's still making the right predictions. But this looks way different. And this could happen, like I was saying, one of the data quality issues that I've seen in the past as well is like if a camera firmware gets upgraded and you didn't know about it, and now all of a sudden the way it's zoomed in is different, or the way it reads images are different. So something like this could totally happen. So if you have this at like a manufacturing station and you're looking at these 2 different boards, all of a sudden something happened where your camera zoomed in or someone bumped it and adjusted it, that can make a big difference. So it's kind of cool that in WhyLabs, right, like we actually were able to see that a big distribution shift happened. It was very bright. And this is just looking at brightness. So there's these other things we could be tracking as well. But just looking at brightness, we can see that, hey, something changed here. Maybe we want to go look at it. And then here, we can see that this looks pretty similar to the other days in training data set. It is a little bit darker. And if we look back at WhyLabs, we can see that, right, this looks pretty similar, but I guess it is a little bit darker there. So it was able to even pick up still that the color looks more tan versus super bright white. Now, day 5, this is where it kind of gets interesting. The background color changed. So if this is in a manufacturing floor and we were looking at these boards, if you've ever worked in manufacturing, a lot of times you have like anti-static mats. Maybe they got new ones, and so the color changed. It used to be white, now they're black. All of our model was trained on this on this other data, so again, it might not be performing well. And going back to that color space question too, of like how it's making the predictions. Well, if the model was basically trained and it learned that anytime there's a certain amount of very dark pixels, that's probably a Jetson Nano. Now, if it's seeing a whole bunch of dark pixels, it might be like, oh, this is a Jetson Nano because there's a whole bunch of dark pixels, and that's what I learned to look at from my training data set. And then quickly, we'll look at data day 6, very similar, maybe a little bit brighter, but also on a black background. And then day 7, the lights went off. So this is super dark. We can barely see the boards at all. And if we go back in WhyLabs, again, we can see that this went from pretty bright to extremely dark there. And so all those ones with those variations, we were able to pick up that something big happened without even looking at the model predictions, just looking at the data. We could say something changed. We might want to go look at our data, potentially fix our model, or fix things like the light is out. We should turn that light back on. Any questions so far? We're going to get back into the code. We're going to log the prediction outputs and look at performance as well in a minute. But I think there's a couple questions in the chat I'm going to look at, but also just pause for a second for you to ask any questions and for me to get a drink of water. Also, do you think this is cool or interesting? Have you used something like this? Do you think this could be useful for a project you're working on? Someone asked, is this model using multi-class classification or multi-label classification? In this case, I think we're using a binary classification because we're just looking at, is this a Raspberry Pi or Jetson Nano? So it only needs to make that decision there. If you go back and look at our model, here, so I think I actually have this set up even. So if you passed 3 images in here, so let's say you want to take this notebook and run it with your own data, and you had 3 different classes. Well, if you have 3 different folders, so you have a Jetson Nano and an Arduino, and then you set the classes to 3, it should automatically configure itself to do multi-classification versus the binary classification. Because it's going to look at this, and it's going to say the class numbers isn't equal to 2. It's going to change the activation to a softmax, and then the units here that's in our output is going to automatically be updated to the number of classes that you have in there. So right now, this is doing binary classification, but the notebook is set up that if you want to put in 3 folders or more and just adjust that number of predictions you're making, it should account for it. Someone said, the tool looks really cool for monitoring models on production. Yeah, it's very neat. So like I said, I've seen a lot of things happen like this in production, even in controlled environments, which is kind of why I made this showing like a manufacturing type environment detecting something and like having a map change. It's kind of based on a real world scenario that I've seen in the past. All right, so quickly, let's run through the rest of the notebook, and I will get to other questions, or if you have any other questions, feel free to go ahead and leave them, but I'll have time at the end as well. So we passed out that Python dictionary. Let's go ahead and look at this. We made it into a data frame. So this has the file name, the predicted class output, and then the predicted score. So essentially, how confident was that model feeling about that prediction? So we have it for all those days, and let's go ahead and log the prediction output. So go ahead and run this. Again, we're just looping through those different days. And then we're logging that class prediction output and the class score output. And so if you go back in WhyLabs here, we had our input tab that we looked at. This has all those inputs. We have an output tab as well. To get things written over in the output tab, all you have to do is include the word output in the feature name. So if you didn't have this output on it, they would just show up in the input tab. And that's fine. Like, it doesn't do anything crazy different in here, but it just allows you to segment your profiles a little bit better, because if you had a features, you might have 100 features or 1,000 features or something like that, and it's hard to find all the predicted outputs. You can just do that easily in these kind of tabs. So we can see that if we looked at the class predictions, we can see all the different classes it predicted on each day. If we go to the class score, we can look at how confident it was on those days. And this is kind of interesting, actually. Again, we don't know the ground truth yet, and we're just looking at our predicted classes. We can see that those first 2 days, it was very confident on all those predictions it was making. And those first 2 days are very similar to the training data set. And if you look on this 3rd day, that's the one where it was really zoomed into the board. We can see that, some of them it was still pretty confident on, but other ones it was way less confident. So you can see this big distribution shift of confidence levels on the model. And then day 4 is pretty confident again. And remember, this data looked pretty similar to the training data as well. And then for these dark ones, it also wasn't very sure either, right? Like, or it had a big range of prediction confidence. So again, without even looking at ground truth, just looking at the input data, we can say, okay, well, we saw that some major changes happened somewhere in our data set here, and our monitor was even able to catch those. And then we look at the output tab, and we can see that, yeah, our model is becoming at least less confident. Like, we don't have the ground truth yet, but we know that our model's probably like not doing as good of a job here, or it's unsure on a lot of these. So let's go back to our notebook, and then we'll go ahead and log the performance data. So we're going to give it ground truth data now. Let's add that to our data frame. Let me double check something here real quick. Okay, so Yeah, I think I made a mistake here when I was making some changes recently, or the data gets shuffled around a little bit. So the the ground truth, a 0 should be a Jetson and a 1 should be a pi. So we can see that the ground truth isn't correct here. Let's go ahead and log this anyway, though, just to kind of see what the performance metrics look like. So I might need to adjust this for the next workshop. Just change this ground truth up. Ground truth, for people who don't know, if you're newer to machine learning, like that is the actual class that new piece of data belongs to. So then you can calculate performance metrics like accuracy and recall, and we can pass these up to WhyLabs. Very similar to like we did before, we were looping through those days. One minor thing is, instead of just logging the whole data, we're logging the, sorry for bouncing around, I lost my place. We're logging this .log classification metrics, and then we're passing the data frame, and then we're saying what target is ground truth, what's the predicted output, and what's the confidence score. And then we're just writing those up like we did with the other profiles. And then we have this performance page, so we can actually see how it's doing here. This number here will be the last day of predictions of how well it did. So in this case, it says 50%. Like I said, I think I messed up the ground truth in there, so take this with a grain of salt here. And if it was correct, because I've done this in the past, you would actually see that it was pretty accurate on all those days. And then those days when the data shifted, it actually was a little less accurate, even on the zoomed in one. And then the ones where it got darker, it got less and less accurate. And then the one where it was super dark, way different from all the training data where you can barely see the boards. This is where it didn't do a good job anymore. So I messed up on that ground truth. Sorry, you can't see those metrics there, but you can see how you would log that ground truth data and then get the performance metrics on your project. And so that's all the exercises we're going to run through today, but there's other resources in this notebook. If you want to learn more about Keras and TensorFlow, these are all good places to go. If you want to learn more about WhyLogs, go to our GitHub. If you want to stay connected with me, you can find me on LinkedIn. You can ask me questions there. But this Slack is also going to be probably the best way to ask questions about using machine learning or monitoring your models in production. With that, though, I'd love to hear, one, do you have any other questions? Was this fun? I know, I think someone said it was pretty fast, but they were able to keep up. Was this a fun workshop? Did you learn something new? Do you think that the tool's interesting? I would definitely love to hear, feedback on what you saw. And if you do use the tool, I'd love to hear feedback on it as well. So if you actually use it in a project or, anywhere actually in production, I love to hear, how you're liking it. And I'll also share, I don't think these are in the description link, but upcoming workshops, I'm going to be going through some of those other things we talked about at the beginning for AI observability, things like model explainability, performance tracing, so segmenting up data and be able to see how it's performing on kind of specific parts of your data. There's a cool blog post about it too, so I'm going to share the link in the chat if you want to check it out before we do a workshop on it. And then also, we just had a cool new feature come out on monitoring embeddings. So if you're doing something like NLP, someone was talking about NLP use cases earlier. Depending on which type of NLP application you're using, you might be using embeddings. So we have some cool way to monitor that. You can also use this for images. So again, depending on what you're trying to log, and you don't want to just log your brightness or mean values like that. Maybe you want to see kind of how the images relate to each other. You could do that with embeddings. So you can follow along the tutorial here. Someone said, do I have any tips or suggestions for multi-class text classification? I would say I'm not a huge NLP person. I've been working a little bit with it more, but I don't know if I'm the good person to give you any tips on it. I've done a lot more with computer vision in the past, but I am starting to get an NLP. So if you have any NLP tips for me, let me know. And I will say we have some great data scientists on our team that do work a lot with NLP, and they're in the Slack channel. So actually might be good to ask I think there's a channel that's just called like ML and ML ops, that'd be a great place to ask any kind of general ML questions like that. Any other questions or comments from anybody? Oh, someone asked earlier if I could share a link to my slides. I should be able to do that. Maybe I'll add it to the YouTube description, so if you come back to this video, because I don't think it's shareable this second, I might have to change a setting. And then I also will do a follow-up email for everyone as well, so you can get the resources here. Oh, someone asked, I think there was a question I missed. So thanks for the explanation. How would you choose a type of classification, especially between multi-class and multi-label? So the different type of classification would be depending on what you're trying to detect. So in this case, go away. All right, so just going back to our, I guess I'll bring up the data here. So in this case, we only have two different classes we're trying to predict. We wanted to predict a Jetson Nano and a Raspberry Pi. If we had a third computer we want to detect, like I brought up an Arduino before, then that would be a multi-class thing, where instead of binary classification, we now have three classes, so we know we want to do some sort of multi-classification on it. And then you're asking about multi-labeling, which I think in this case you're talking about when you do classification, you could train multiple models or a model to predict multiple labels for each image. So in this case, if I wanted to understand not only that this was a Raspberry Pi or a Jetson Nano, but I wanted to know, is it also a computer? Because maybe our data set also might have fruit in it, like an actual Raspberry Pi or something, right? And then so a multi-label classification would be that if this had multi-labels attached to it instead of just Raspberry Pi, it might be like, this is a Raspberry Pi. It's also a computer. It's also a B+, which is a version of the Raspberry Pi. So if it depends on like how many things you want to predict around your image. So a good example of that too is like if you have a painting and you want to classify, well, okay, it's a painting. It's also a Van Gogh. And then maybe you actually want to know which painting it was. That could be a separate classification on it. And there's also different types of computer vision ways of making predictions with computer vision. So I've done classes on this in the past, and it might be fun to do again, where instead of just doing classification, you might want to do something called object detection. So instead of just knowing that a Raspberry Pi is in this image, you might want to know approximately where it is in the image. So an object detection, that draws a rectangle around that object. So in this case, we would draw, well, actually, maybe I can do that with a shape here. Object detection would look something like this, where it's going to draw a bounding box around where that image is. And then with that, you can do really cool stuff, because instead of just knowing if something's in an image, you can know how many things are in the image. So you could actually count there's 2 Raspberry Pis in this image. You can know where they are. So you could do something called object tracking, which is a little bit different. So now you know where something is. You can look frame by frame, like did this thing move and did it go over a certain line or something like that. And so you could actually count it. So if this was going down a conveyor belt, you could have multiple Raspberry Pis detected with the bounding boxes, and then see when those Raspberry Pis like went over an imaginary line or something, you count them as counted. And then you have instant segmentation, which is instead of just drawing a bounding box, it's actually really traced around the object, and that could be a little bit more precise. You can also do some more interactivity stuff with it. So if you're detecting hands and you want to know when like a finger goes over something, like in a VR application, you could use something like instant segmentation. I don't know, did that answer your question about classification? And then I kind of went off on different types of computer vision. Would anyone want a workshop on using different types of computer vision? Maybe even tying in monitoring again, but on object detection, for example, because it is a little different. Instead of monitoring the whole image, you want to figure out what you want to monitor about the objects themselves, and maybe even like their sizes. They said it did answer their question. Awesome, great. If there aren't any other questions, I just see people saying thank you. Again, I want to say thank you for all coming. It was great. And thank you so much for asking questions and participating in the chat. Always makes it way more fun for me. And they said yes to another class. Awesome. And again, I'll share the link again. If you go to the WhyLabs.ai/events, I do have a whole bunch of stuff coming up. Not all computer vision related, but if you want to learn more about understanding models in productions, or in production, hopefully it'll be really fun. We're gonna go over kind of the basics. It'll be maybe what you saw a little bit today, except for with different data, so it will be different. And then we're gonna go into the bias and fairness, and then we'll go into explainability. So I think those will be really fun, especially if you're just kind of getting started with ML in production. Hopefully this will be like a cool place to learn how to, make sure that it's robust and responsible. But with that, yeah, I just see people saying thank you. So I want to, again, say thank you for everyone coming out. And I'm going to go ahead and wrap up the stream. But if you have any questions, join the Slack channel, ask them there, or connect with me on LinkedIn and ask me there as well. So thank you again, everyone. It was really fun. And I always have a great time doing these workshops, especially when people are chatting. And it was really great to have your questions and comments today. So with that, I'm going to go ahead and end the stream and hopefully talk to some of you later. Have a good day.